Alright, hello everybody. How goes it? Just get my terminal up real fast. So, big moment happened yesterday, and that big moment is, we finally got the scripting language working. And apparently my Vim is broken. Oh, right, because those files don't exist anymore. But to kind of show off what's going on here, since I didn't actually show a recording in the Discord, I just posted screenshots at, trust me bro, it's working. But no, it is actually working. So once this is done compiling and actually boots up, we will see that. But yeah. So once it fully loads, it prints out pretty quickly. I'm concerned about losing the log here. I might see if I can get the terminal to run externally so I don't lose everything. But you can see the second half of that function's there. I edited the debug output of the intermediate representation so it actually shows which operation is which, because these variables here on the intermediate representation are which previous operation's value it's using. So it is like a SSA form graph basically, but pretending to be a register-based virtual machine. Resorting to dark rituals now to help you make it in time for AWE. I think I'm actually giving up on the AWE thing. I would probably legitimately nearly kill myself trying to actually make it to that deadline, especially with other work. So the much significantly more flexible deadline I'm putting on myself is Stanford's hackathon in November. I think that is that's far enough off that I can see myself actually reaching that deadline now, especially with all the Rust rewrite stuff I'm doing. Which, to be fair, the Rust rewrite for Brane script is already done. That's fully done. We're further along in Rust than we ever were in C++. So that's good. But yeah, so of course here's the LLVM intermediate representation that we generate from the bitcode. So here's the Brane script IR, and then this gets turned into actual instructions. And the reason why there's significantly more LLVM instructions is because all of these, there's a lot of 3-operand things. A Brane script IR thing will expand into 3 actual operations. So for example, anytime we do a load operation, this takes in a 32-bit integer, and then behind the scenes, that 32-bit integer is split into 2 portions. So let me actually see if I can find this. Yes. So we shift it right to get the binding index, and then we do an AND operation to get the lower 16 bits to get the memory offset or index, and then we do a get element pointer to get the actual index of the memory to access, a load operation to actually get the pointer to that memory that we're accessing, and then we do another get element pointer to then shift our pointer to the actual spot in memory that integer wanted. So accessing an integer pointer in Brane script does like take I want to say yeah, it takes that many operations. Looking dangerously close to straight up assembly there. It is. Like, no, that's exactly what it is. This is LLVM intermediate representation, which is the thing. LLVM is a compiler backend. This is a compiler. So this here, this is like a unholy amalgamation between WebAssembly, which is assembly code, and SSA format, which is kind of register-based stack machine where you can't ever assign to a variable multiple times. Yeah, there's no actual registers here. I let the actual JIT runtime do register allocation, but it's assembly code without registers. It's assembly code operations. But yeah, that it gets compiled down to actual assembly code and then it actual machine code. So when I do here, let me actually just show what main looks like here. So this is after all the compilation has been completed. These two lines here are where we grab our functions from the runtime, and those functions are completely JIT compiled. They're now machine code that we get a actual function pointer to. Like, there's no interpreter, there is like kind of a runtime that manages the memory for those, but there's not a runtime in the sense of a garbage collector or anything. We're going to be writing a runtime, but like the actual functions themselves aren't run by anything other than the CPU. This is straight up machine code. And then we create a stack page. So this is all the memory that we're going to give the scripts access to. I'm doing the WebAssembly thing where scripts don't have any access to any memory, not even the stack. I tried doing the stack, but it was making it really hard to figure out how to like give them secure access to the stack, but without it was just hard to like let them access dynamically allocated memory and the stack at the same time. So I'm like, okay, we'll just do what WASM does and have them use the same memory system. So it's as fast as a regular stack. It's just allocated behind the scenes in heap memory. Or in this case, it might actually be on the stack since this is a statically allocated vector or slice. But anyway, we have a stack page and then we have a bindings page. And this bindings page is the list of every single memory page that the script can access. And right now it's like uint16 max. So we can change the size of this binding page at will. It can be at max, the uint16 max, which is 65,000 something or other. I can actually see in the assembly code here. Yeah, 65,535 is the maximum value of memories that could be bound to this. And we can also dynamically swap those out as well, so we can access more memory than that amount at runtime, as long as it's like using the bindings too. The bindings that we haven't created yet to swap them out. But then I allocate one argument struct. Technically there's a couple. If we're referencing our example script here, this is what we're actually compiling. So the first argument is like start, add, and add to. basically we're just doing 2 addition operations. And then this one, what it returns is the result of the add and then the other operand to be added. I'm kind of templating out an async pipeline. There's no reason for this to be asynchronous because it's just 2 add operations, but I don't know, it's cool. There's one addition that happens in one and then another addition that happens in another. So yeah, we pass the added value and the next value to add to the next stage in the pipeline, or at least that's what the grammar is representing. Behind the scenes, these little parentheses, this is like an anonymous struct, and that's constructed as a struct on the stack. Technically, we should be able to optimize that out if we wrote an actual optimizing compiler. Or we run LLVM optimizations after the fact. That's something we'll have to look into later. But then the second second pipeline stage takes the result of the last stage that was passed here, and then does another add operation, and then we call next stage again with the result of that, and that's what returns. And it could be next stage, it could be break. I haven't really fully decided on what I'm calling these flow control functions, but showing what that looks like from the caller side, we have our memory. I made an arbitrary stack offset because we can tell the actual function signature that we're calling from the runtime side of things is, where is it? If I go here to the functions and then JIT function handle, it's right here. So it's a raw function that takes in a pointer to an array of bytes, and that's like our bindings list, and then the actual memory bindings. So this is the memory we want this function to operate on. Always been more nervous about low-level code like this. The names feel less clear. You have to do more explicitly. It means that you can do stuff improperly and mess something up. Yeah, that's one of the reasons I switched to Rust, is it has more safeguards against doing stuff that you don't want to do, and that's especially important when I'm writing a language runtime. You know, it's one thing for your code to be broken. It's another thing for the actual script runtime itself to be broken. Me when the compiler is actually wrong. But then the other thing we pass into is the pointer to the start of our stack frame. So this is the stack pointer, and the script itself isn't able to actually change this. That's all handled by the JIT runtime. When it compiles the structure, the intermediate representation can't access this, but it's compiled in such a way that it does affect that. But yeah, this is just a pointer to our input struct. So we do pass input through the stack, essentially. So what we're doing here at first is we have this arg struct that can represent all of our input and output values. And then here I just grab a reference to somewhere in that first memory page. I have the stack pointer arbitrary offset. So if we look at the, this is kind of a debug thing to see if it actually works. If you look at the stack before call debug, you'll see that there's like 4 empty bytes before any data in here for every single one of the calls, and that's this value here, is I'm seeing if that input pointer works. So I could also change this to like 32, for instance, except I have this as 40, so let's change this to like 20 instead, and hopefully that doesn't cause any exceptions with like unaligned memory access, but yeah. And then after we have that, we get our pointer to the arguments. We set the arguments to 5, 3, and 11 respectively. Print out that debug stack, and I was lazy, so we just do new lines with print statements. And then here's where we call the first function, and you can see we just pass in the bindings page as a pointer, so this is a pointer to a list of pointers. And then we also pass in our stack pointer, which is a 32-bit integer with the high set of bits representing the memory page and the low set of bits representing the offset within that memory page. So you can add and subtract to that the same way you would do a regular pointer, and it will add and subtract within the memory page that it's bound to. And then if you add too much, you jump to another memory binding, which is behavior that we should guard against at some point with like debug assertions. But then after returning, we print out that arg struct again. So it will, right now the way that I have returning of functions working is it'll destroy its stack and then print the return values where the input struct was. So it overwrites the input struct with the output struct. So there's like that implicit, before you call any function, if you don't want to affect the structure that you pass in, you do allocate some memory and then pass it in. But that's all handled by the runtime. You don't need to worry about that as the coder yourself. Yeah, and then we just pass literally the same thing that we passed the first one. We just pass it the binding, or the result of the last function, because we want to pass this to the next stage, so then it gets passed in here. We do another add operation, and then we get the actual results. It did. That's right. No, I didn't. There we go. I can't accidentally move myself anymore. Let's see, what was that? I had a pop-up. Or it was just the bindings, or... Okay, yeah. It was just the bindings were turned off. And yeah, that's what we have so far. And like, the only operators that are actually implemented are the add operators themselves, and like, we don't have implicit function arguments because this is secretly also a struct that's getting passed into a function. So anytime you see parentheses with named arguments, all of those are implicit struct definitions. So like, next stage literally is a structure itself. Means I could do interesting stuff with like reflection and whatnot, but yeah, we don't need to worry about any of that quite yet. Whereas it'd be kind of fun to do a thing like, since this is implicitly a struct getting passed into a thing, if I did like function calls with that syntax of like, into this pipeline or function, pass this structure, that would be a funny syntax. Because you just see tons of arrows everywhere. That would also mean you'd be able to do stuff like, into A, pass the result of B from C. But I'm worried about, obviously, making a language that's just impossible for people to understand. or like has that learning curve, even if that would be cool. There's also the problem of like it's not super ergonomic to type arrows everywhere. Even if I'm very used to that arrow syntax. Alright, to get to the actual, like, what are we doing this stream? I was just gonna take some time and flesh out the rest of the language. We're probably going to go, just gonna be a shorter stream today, since, or the last couple days, I was like super rushing to try to get to a sort of pause point, because for Team G, we're gonna be doing a game jam, so I need to like have more time for that. Not as much time for streaming. So let's jump right into it. What do we want to add? Let's do a subtraction here and just implement more. I think I already implement all of the operators into the compiler itself. But then again, I did want to do signed versus unsigned and have that work properly. With like division and whatnot. And I did end up deciding that I do want the intermediate representation to be more explicit rather than implicit, because I was going like the implicit route of like, if you do an add between two I32 values, then, you know, it's just implicitly like works that way. Means I don't need any like unsigned types actually in here. Technically, I do want to keep unsigned types in this because we do to the runtime report what types everything is. So we need that. But for the actual like bytecode representations, it doesn't. This is just a int32 value. Floats need to be different because they're stored in different registers. And they have a different data layout. But yeah. So remove the signed constants, or the signed variance of constants. And then for all of these, the size of the add operation doesn't necessarily matter. Most backends, maybe crane lift is different. I should probably check what crane lift, how crane lift works. Because there's a very good chance that I will write a crane lift backend for this to complement the LLVM backend. So if I can see a world where on standalone headsets you use the crane lift backend because the compilation pipeline would be significantly more efficient. But on PC you use LLVM, where there is a much higher initial cost to loading scripts, but then the scripts themselves are faster. Meaning, like, PCs would have more headroom to do more cool stuff. It's like, do you want to pay the cost now or over time? Sort of deal. Target independent intermediate representation, so let's see what their IR looks like. It probably looks... Oh, it looks very similar to LLVM IR. with 64-bit pointers. Okay. No, this looks very, very similar. I add IMM. It is SSA form as well. I could tell. Has all the same integer types as I was targeting. It can only represent F32 and F64 types. LLVM is able to represent 16-bit floats. But this looks like it isn't. So I'm fine with my, like, only having 32-bit floats in here. 16-bit floats, you don't... I think they're, like, faster for GPUs to compute. Because one of the things you have to worry about on the GPU is the amount of data you can pipeline through things. They do support SIMD vector types. In media operand types, these are not part of normal SSA type system. They're used to indicate the different kinds of immediate operands on an instruction. Immediate 64 A is an immediate integer. The value of this operand is interpreted as a signed 2's complement integer. So this is assigned. I wonder, do they have a builder? And do they have a crate? Oh, not a crate. Okay, good. I don't have to clone the entire WASM repository. This is Umbrella Crate, which contains no code of its own, but pulls in other Crane Lift library crates to provide a convenient all-in-one line dependency as a prelude, and a prelude for common use cases. Okay, so let's see the dependencies. So there's the code generator, there's the front end, so this is like a builder. Oh, interesting, they have an interpreter. There's the JIT. And then there's like caching files if you want to. I'm most interested in their front end. Create a crane lift IR function and fill it with instructions translated from another language. Contains an SSA construction module that provides convenient methods for translating non-SSA variables into SSA crane lift IR variables, the use var and vardef calls. I desire the documentation. There it is. This API has been designed to help you translate your mutable variables into SSA form. Okay, so they have helpers for that. If you know beforehand that one of your variables is only defined once, for instance, if it is the result of an intermediate expression in an expression-based language, you can translate it directly into CraneLift IVAR or value by returned by the instruction builder. We use var API for such an immutable variable. It would also work with a slight additional overhead. Okay, so instead of... I mean, my solution is just to have memory addresses, but So I'm not really able to super take advantage of platform-specific variable optimizations. Since I already have it in SSA form. Unless I actually put lambda statements into my intermediate representation. Or like a mutable variable type. But I think for now, just having everything like on the stack is fine. Mostly. But it's good to see they do have like a builder system. There's your integer add. Right, what I was going to check while I'm actually looking at this is, does the size of integers matter, or are they implicitly determining that? Because this doesn't look like a sized operation. So builder, what is the type of builder? Function builder. Then builder insert. Insert is probably into the current basic block. Yep. And this, oh, so that's what that stands for. Func instruction builder, function instruction builder. So there's your generic build function. And then this, I'm guessing, is no. Looks like there was a trait that defines all of the other stuff. Yes. Oh, interesting. They have a swizzle command. It's not. It just means, like, you're mapping one vector to another one. So there's, like, your integer specific, like, iStore unsigned load. Is that supposed to be unsigned? Why are the, yeah, signed, wait, I-U-S. An integer address type, offsets. It's 16 bits from memory. Both of these, oh, okay. Unsigned extend and signed extend. So this is for, like, bit extension. Wait, can WebAssembly stack values only be 32-bit integer? Wasn't only why do you need to sign extend a 16-bit integer though? I'm really wondering why that sign extension. I really should learn more about what sign extension means. I will put that in my notes to read up on more. Because like, if you just load the values from memory, you don't need to sign extend it unless you're loading it into a memory address that's bigger than 32-bit than a 32-bit variable. Because sign extension is like when you need to load more bits. Yeah, when you need to increase the number of bits. And you do that differently depending on if something is positive or negative. Because if it's a negative value, then you need to extend like it differently. You need to put like ones there instead of zeros. If it's currently a negative value. So I am wondering why there's so many sign extension things. I guess I could look into mem flags. Yeah, so there's no flags here that tell you the size of the thing. I do like seeing all the SIMD expressions there. That means in the future I will be able to add like SIMD optimizations into both backends. Sending loads and truncating stores. Here it is. Provide instructions to load an integer value smaller than a register, then extends it to the width of the register. Similarly, store instructions that only write to the low bits of an integer register are common. In addition to the normal load and store instructions, BraneLift provides extending loads and truncation stores for I16 and okay. Well, getting back to this, all that tells me is they do have generic commands for stuff, and like the actual intermediate representation isn't generic, but the builder is. So I can keep like the size of the variable operation generic, like add and subtraction, those are generic. But we can... Oh, well... Guess it depends on what output value you want from them. I wonder if I should put like an output value on here. Because it's either I do signed and unsigned multiplication and division, or think you will ever resort to building the firmware for a custom headset that runs this natively like part of its OS? I don't think I need to go that far, because I've already gone far enough to make this run on stuff it's not explicitly like designed to run on. And the intermediate representation is generic enough that it's not a raw bit code that could just be run. Like there will always be a JIT step. So without a slight redesign of the language at this point, I guess you could ahead of time compile for a specific headset. Basically the answer is I don't think I need to get the results that I want. Like it's still going to be one of the fastest scripting languages out there with the current course that I'm going. So do we want to say explicitly what we want the return type of this to be? or just have it implicitly be the result of the two values. I guess right now it already is implicitly part of the two values. I wonder how LLVM-IR represents the return values. Because, like, if I tell it, hey, add this value to, like, add a 16-bit integer to a usize, does it return a, or if I say add the 16-bit integer to a 64-bit integer, does it stay a 64-bit integer in the output? Here we go. No, that's an allocation. Where's add? Here's the add. Add I32. Okay. So it does have the type as part of the add operation. Then if I look at crane lifts IR, you can see the iadd operation. The instruction itself is the type to add, I guess. Because iadd a pointer-sized integer representing an address. Or iadder. That's different. Declare a global value which has the value of base offset divided by offset, or I add immediate value. Wait, aren't immediate values what they call constants? Yeah. This is adding this immediate to value 4. That's what's going on there. Very WASM or WebAssembly. This is a float division. How does it... So that's a float 64. These two values that it's dividing are float 64s. And here, V4 I'm not seeing a value 4 anywhere. Where is this defined? So we have system v value 2 equals value 3 equals. I guess it just multiplies v4 by 4, even though v4 doesn't exist. Oh, wait. It's an argument to the block. Never mind. So when we jump to block 3 here, V3 gets turned into V4. That's what's going on. If I do want to represent basic blocks in the intermediate representation, I might have to do something similar to this. I don't want to have to learn LLVM lambda statements. The point where in their Kaleidoscope tutorial they're like, yeah, just use this optimization pass. where you just upgrade stack memory to pointers. Yeah, function lambda. I need the LVMIR. Sorry, I'm going on a complete squirrel right now. Awesome devs. So the good news is we're allowing use of something other than JavaScript for WebAssembly. The bad news is it's assembly. Well, that's actually the good news, because that means you can compile whatever you want into assembly. Theoretically. And there is like pretty wide support for WebAssembly compilers. Like Rust has it as a native target of their compiler. And then like Inscription is like a pretty good compiler for C++ and C. I know like I've worked on game engines where the runtime was written in C++ and then compiled into WebAssembly. We don't want that gentle introduction. We want the raw, uncensored introduction. Okay, what was it called? There's like a join. Okay, I need to look at the... I guess that's not the term of the thing. So if we go to the Kaleidoscope tutorial and look at control flow branching, there's basic blocks, and then you have to say that like a value could be the result of this code path or this code path. I guess we aren't doing optimization passes. Wait, are mutable variables after control flow? So code generation, optimizer support, language control flow. Yeah, mutable variables is all the way down here. Yeah, cause complexities in a single static assignment, so you can't... SSA form basically means you can only assign to a value once. But what if you assign to a value multiple times in a loop? Or if there's an if statement where there's like one possible value here and one possible value here, and you need to define both of those in the graph, so they have different value names, but you need to use one or the other. How do you represent that? Called a phi node. It's not called... It's not called lambda. It's called phi. The condition true, we have this value, and a condition false, we have this value. And then we need phi, where from that label, we get this one, and from this label, we get this one. However, SSA construction requires trivial, non-trivial algorithms and data structures. It is inconvenient and wasteful for every front end to have to reproduce this logic. And the trick is they literally tell us to use analysis passes, which convert stuff on the stack to stuff on the heap. The problem is that the way that I handle my language is everything is not on the stack, it's on a virtual stack. So I don't think this optimization pass will work. I'll have to actually learn the non-SSA system for that. But that's for when we implement control flow, which we're not doing yet. But it's just like the seeing the block having input here was interesting. So yeah, this is a full I64. And then we're adding, I guess, an immediate value. Yeah, even in here, both of these are 64 bits. So this add command is like fully generic, even in their intermediate representation. Unless every single value is bit expanded to be 64-bit. Many instructions are polymorphic. They can operate on different types. Of these types, I32 and I64 are the most heavily tested because of their use by Wasmtime. There are no known bugs in I8 and I16 and I128, but their use may not be supported by all instructions in all backends. That is, they may cause the compiler to crash during code generation with an error that an instruction is unsupported. That will be fun. There are no known bugs. We're not going to say there are no bugs. We all know that would be a lie. We just don't know what they are. Yep, so when my runtime, crane lift runtime is blowing up, I'll have to spam pull requests. Those are your function calls, memory. I guess there will be a section here on math operations, wouldn't there? But no, they just have vector types, immediate operand types, control flow, memory, global values. Here's bitwise operations. So this is literally the this is the docs. Wrapping integer wrapping integer addition. This instruction does not depend on signed unsigned implementation of the operands, and doesn't care about types either. Nor does it return any errors either. It just goes, okay. Maybe when we do the final build command, it actually validates everything. I am just very concerned on like the addition side of things. I guess I could just, for now, take the Rust route of literally forcing both arguments to be the same, which is what I'm currently doing. And then I'll follow the trend of doing, like, there's signed multiples and unsigned multiples. Remainder is also, like, a division operation. Yeah, unsigned and signed remainder. And I think the rest of those make sense. So now we have our actual signed types. Let's go to the compiler. And now we need to, inside of compile binary operator. When we implement traits, that's when we'll need to put in the ability for us to override operators with traits. But for now, For all of these, I wonder if it's possible to like do match statements within match statements that use the same little bits of logic. So here we have the left op brand type. Or honestly, what we could do, since I like this. We will use the left type as the type. So then in the future, when we're figuring out like operator overrides, it's like the left types overrides to access stuff. So then we can do a match statement here. I guess I kind of do want like subtables. Because I would like all of these to be their own match statement with stuff that happens beforehand. Now we know that all of these are for native types only, and we can keep the logic that way. And since for the moment we want to enforce that they are the same type, we can just do right type is equal to match right dot r. Is equal to type context. That's what I'm missing. And then for struct, we also want to bail. And then for... Oh, wait. I don't want to bail for native. We want to bail for struct. There we go. So now we have both native types. And we'll say if L type is not equal to R type, then we want to also bail. Say and then I'm going to say that type and that type, which is F type R. We used to have a little bit of indication of what's going on there. And now I know for a fact this will return correctly. Instead of ops type here, we're going to do L type. Add sub mul div. Do I want to do unsigned at? Do I want this writer class to take care of signedness? Since I'm passing in the type, I might as well also handle signedness. So we will copy this function, paste it 3 more times. Actually, we need to paste it 4 times because we're doing remainder as well. So I'll just boop or. So this is addition. Do ir op subtract. And that works fine that way. And for multiplication, we do need to match do I want the type as part of it too? I think I do. I look at the runtime. Just takes an integer, and that's the same thing the other runtime takes as well. So I only really need to do int versus float versus vector. So add I, add f. Maybe we should do it before. It's probably clearer to read if you do the type afterwards. Subtract integer, subtract float, and then here, for signed and unsigned multiplication, it's actually super easy. Because we only need to add one more here. Because floats have their own way of handling signedness, which is always being signed. And then there's no such thing as a remainder function for floats, I believe. Yeah. Integer type, integer type. Where's float compare? Where's mine? Okay. Float compare. Those are floating point constants. Oh, interesting. You can do bitewise ORs on floating points too. I guess that just happens in, I think it's the XMM registers. Floating point comparison. There we go. Float add. Yeah, it just goes straight to like a square root and multiply and add. Interesting. Interesting that that has to be an instruction itself. Float, multiply, and add. Yes, do I want to implement... I'm gonna add compare to the name of that, just so it's a little bit clearer that those are comparison operations. But we'll get back to that later. So let's add all of our addition stuff. Where was... I like squirreled right in the middle of adding these. So multiplication, division, and remainders. And maybe I copied these too soon, because now we actually do need to match on the type. What language is this? So what you're seeing on the left is Rust, which is what I'm writing the runtime for the language you see on the right in. So left is Rust, right is the custom language I'm writing for my game engine, Brane script. Thank you. This is going to be the unsigned add integer. Interesting that my expected semicolon where? Or there we go. So is this add you add I? Was that how I did it? No. Right, because adding isn't signed, it's just integer versus float. We'll implement the float as well. Alright, let's try our hand at making an action do this for us. This is going to be a very inefficient action. But theoretically now, if I do this, it does it for us. It's nice when I remember Vim features. There we go, and I am definitely copying this and renaming it for doing subtractions. And all of the other functions, which I might as well just delete and then redo. Actually, it's probably jumping the gun to already define them. Let's do one at a time. So we'll do subtraction first, so subtraction integer, subtraction float, and then multiplication is fun because we have to do signed versus unsigned. Which means I actually have to let's organize these by signedness. So there's all of our unsigned theirs together. Not, you know, organized. Which I would like them to be, but there's all of our unsigned values. Copy this expression. And then need to rename this to multiply, rather signed multiply integer, which I believe is what I called that. Oh no, I just called it smol, umol. So these are implicitly integers. Right. I guess if I want to keep consistent with this. I should rename these so that you're consistent. Wait, not and, we want float, add. How long do you think your project as a whole will take to complete? One, it's never going to be done, but like the real question is, when will it actually be usable to make projects with? And my like current deadline I have for myself for like being able to hackathon with it is I'm gonna try to make it to Stanford's XR hackathon happening in November. So that's like my target deadline for having something working and usable. For like actual projects, probably like a couple years. And like with coding, like you can't really do specific deadlines because you just straight up don't know how long things are gonna take. The longer you code, the less you like know how long things are going to take. Unless it's something you can literally do instantly. The answer is I'll have that done in an hour, or I will have that done in 2 months. And depending on specific bug and how hard it is to fix specific bug. Okay, it looks like these got renamed correctly, so we have signed multiple, unsigned multiple. Well, actually, did they get renamed correctly? I'm not looking at the ones that got renamed. Float, sub, and add I didn't get renamed. Because I didn't use the rename command to do it. Okay, and I think that will work. Let me just change this to divide. Finally, we get to do remainders. And for remainders, we just want to throw an error that Can't get the remainder of floating types. So we don't need to do any extra stuff. Come on, this is... Wait, this is the compiler. Yeah, this is the compiler. This is the correct place to be. But why can't I find the expressions? Oh, here it is. Oh, it's writer, not builder. That's why the lookup didn't work. Hello. Alright, so now the intermediate representation will be outputted. Let's check how... Now we need to actually implement it in the back end. So we'll go here. And this file should be throwing up a ton of errors. But it seems like, oh, it's because mod, like, common isn't working. So I need to fix this. Oh, right, because there is no unsigned sub, it's just float sub. I keep tripping myself up with that. Integer, or rather, signed, unsigned, float. Unsigned, float. That is not the most readable. We'll add the underscore in there to make it human readable. There's no diagnostics to move to, which means that, yay, error checking is working in this file again. Is that another Outer Wilds world? No. This is a world called... Let me get it right. It's called Blackfire. It won some awards, and it is a really beautiful world, just throughout the entire thing. It won, like, art direction awards, because it is very artistic. Gamma Fire isn't black? Okay, it's like the closest you can get. That's like how a black light is that color. Like UV light. Is that what your doctor told you? Definitely not. Yeah, definitely not. Because that's how BraneScript suddenly started working. I made some deals off stream. Yep. I wonder if there is... Does basic enum value have a try into implementation? Like, could I do... Let some right, left equals right try into left try into. Because if it does implement try into, that would be incredibly convenient. Well, that's just the trait itself. Ah, right, I need to do the sums individually. Or rather, not sum, we need it to be, for integer add, we need to make sure these are integer values. Other players somehow showed up with a weird avatar whispering about dark bargains. What kind of rest wizardry is try into? It's like an attempt at a cast. So into is a cast that you don't like explicitly say, like there's into int value, which is their implementation of like if this is an int value, otherwise oh it's a straight up panic. I don't want to do panics. This crashes my entire program. So I want to do try into instead. So it has try from, like, basic enum values. Wait, from any. So lots of, like, different enum casting stuff. Int u unsigned int. In addition, they on the assembly language side, there is no signedness. Your compiler doesn't know what signed versus unsigned types are. There's only signed versus unsigned operations. And in the case of add operations, because of how integer types are stored on the CPU, for addition and subtraction, it doesn't matter what sign variables are. It does for multiplication, division, and remainder operations, but for addition and subtraction, like the overflowing of an int, yeah, that's just how integers work. Like, once you get over the integer, like halfway through a signed integer, where like an unsigned integer would just keep going up, an unsigned integer, the middle value is the negative max value. And then like as you like continue adding up, the negative number goes down until like at the max value of an unsigned, it's also the -1. So when you add numbers together, signed or unsigned, that mathematical property makes them just work. Like, you can add them both interchangeably and it just works. And overflows work exactly how you'd expect them to. I guess I can just do an if let sum. Or I guess turn this let into an if let to unwrap the values. Try into would have been fun though, because then I wouldn't have to do this, which is then is there debug or display traits for these? Option value. Ah, right. You're not getting me with that. But this project was C++, and then I rewrote it in Rust. I did the meme. It only took me a week. I guess these do implement the display trait. Nice. But then this is float edition, and we'll just say float value. I add args, we're not both float values. And then I'm just going to nuke every single other one of these. And then re-implement them. And then this isn't build int add, this is build float add. Just realized if I'm going like explicit for all of the different things, would I have to do that for the compare operation? I mean, that's what WebAssembly does. Man, I want to nest these so I don't have to do the get value for every single one of them. That's not too much overhead. Rusty Wasm. No, it's its own thing. With its own innovations. Like, not needing to allocate 4 gigabytes of RAM for their security concerns. Okay, that looks all implemented. Next we do multiplication. Build int multiply. New unsigned. What? Need to figure out what the differences between these are. Which one's signed? Which one's unsigned? Do you prefer Rust to C++, or what was your reason for switching? Greatly prefer Rust, especially when you're dealing with walking trees, which is the majority of what I'm doing. Like, just the match statement alone makes it worth the switch. One singular grammar concept. No unsigned wrap. Values produce integer sums. The no unsigned wrap, signed wrap respectively. If the no unsigned keywords are present, the result value of the add is a poison value. Result of erroneous operation. In order to facilitate speculative execution, many instructions do not invoke immediate undefined behavior when provided illegal operands and return a poison value instead. The string poison can be used anywhere as a constant. A constant is expected in operations such as add, where the no signed wrap value can produce a poison value. Most instruction. Oh, interesting. So I don't want to stop it from wrapping. This is weird. Is it only division and remainder that require signed versus unsigned? Your pressure probably has something to do with it too. No, I am an entirely independent thinker. People could never pressure me into switching languages. And if they did, that probably wouldn't be recorded on stream at some point. Yeah, I wasn't clear on if multiplication was... I guess, yeah, with multiplication it wouldn't matter. I remember when I was learning assembly, there was other stuff to do with it. I guess if I were to do... Yeah, it's signed and it's only division that's signed versus unsigned. Only division. Well, I guess I am undoing the many changes I did to... Guess we go to int multiplication and then that, but we can keep the rest of it the same. You really need unsigned? Yes. I like unsigned variables. Have you ever had like a score in a game go negative? That's because they didn't use unsigned variables, and it's a very strong pet peeve of mine. If a val is greater than 0, val equals 0? No, what? What? No. Unsigns are good because they can store twice a higher number than the signed versions, because they use all the space that would be used to store negative values for storing higher positive values. And why would I add an if statement? That's extra computation. No. And also, your UI would still be glitching and not showing you the correct score. Add another long? You run out of them eventually. And also, what's this, like, calling variables long? How long is a long? That's very vague. Just give me, like, I32 versus U32 versus 64. I want to know how big my variable actually is. Not binary operator, we need the actual, like, code. Well, I know how long. I know what the variables are. Like, I spent enough time in C++ to know. But that's the thing, it's implicit. There's a learning curve to that. I want there to be. I want the language to not hide things as much as possible, or at least make it feel like it's not hiding things. The parts of it that you use, the things that you use aren't obfuscated. It's programming is an interesting thing because you get very Stockholm syndromed into all of the foot guns that you've learned. Like, I was talking to an Unreal dev recently, and they're like, they love Unreal because of how much more reliable the physics system in Unreal is than in Unity, like, fresh out of the box. And, like, I have done a ton of physics stuff in Unity. For every single thing he said doesn't work in Unity, I know the workaround to how to get it to work in Unity. But what was interesting about the conversation was it made me realize, like, every time it was like, oh, you just have to know this thing. Oh, you can do that, you just have to know this thing. But in Unreal, you don't need to know something, it just works. And that made me realize, I need to make sure I'm careful not to put, like, the same foot guns into, like, the stuff I build because I'm conditioned to them. Like, I need to make it intuitive to, like, when you could make something in such a way that people wouldn't have to read the documentation for it, you should probably do it that way, as long as it, like, doesn't significantly hamper performance and whatnot. What are your opinions on using AI for coding? Do it as long as it doesn't hamper the quality of your work. It's free. It's a tool there that you can use. As long as you aren't sabotaging yourself by doing it, use the advantages you can get. If you are trying to learn, though, don't use AI. It will completely nuke any ability to, like, well, not completely nuke, but it will significantly hamper your ability to retain what you've actually coded. So while you're trying to make, like, a mental map of how something works, having something else do the work of mapping it out for you will sabotage that for you. So if you're building something and you don't care about learning, use AI. And if you already know how to do what you're doing, like, please make Brane Engine have deterministic physics. Oh yeah, of course. Like, I'm trying to do networking. Like, network physics. Of course it's going to be deterministic. Oh, not you. Just float. Wait, did I sub F sub? Okay, good. This is how many R's are in strawberry? True. I've heard that Claude builds an entire JavaScript web page to count it for you, if you ask it that. Haven't tested it myself. So now we need to do division. So it's like sdiv. Copy multiplication. So I don't have to redefine everything for the floating point version. Tried that with Copilot, and it got it wrong. Didn't have a hard time correcting it. Yeah, I don't know. Well, I don't. Yeah. Tokens. Because of tokens, I don't think LLMs see individual letters in words. They see tokens, which are chunks of words. So it can't actually count it. Right, this is going to be F div. And then this is going to be S div. Int signed divide. And we need unsigned. Then I'm going to copy these for remainder. Okay, and then these are just now compare. Actually, the last couple aren't. There we go. What is the S prefix? Signed. Signed versus unsigned. So U is unsigned, S is signed, F is float, obviously, and then in the case of both signed and unsigned being handled by the same case, I just do I for integer. So I think that fully implements basically all of those operators. No sign unsigned for floats. Floats are only signed. They can only be signed. Though when you compare them, they set unsigned flags for comparisons, which is luckily something I don't have to worry about because every JIT runtime extracts over all of that madness. At least on x86 registers. They do unsigned flags for the signed floating point variables. Expected IR writer value, found result, wonder how that happened. Did I just do some operation that deleted every 8 in the file accidentally or something? Wait, was you... I guess U32 was the only constant I was using, and that was the one that I deleted. Or rather, only constant that I had implemented. I guess I did do some operation that, deleted every 8 in the file. Is the whole engine going to be rewritten in Rust, or only the scripting engine? At this point, probably the whole engine, because I've already been doing like a full engine rewrite, so at this point it kind of makes sense to like just continue the rewrite in another language. In fact, the reason why I stopped working on it and went over to the scripting language is because there were language features in Rust that I wanted to be using for like all the serializer stuff. And I thought, hey, I'll just finish my scripting language, put those features in there, and that way I'm like not just jumping ship to Rust. But now, of course, I actually am using Rust for stuff. So either I still like the idea of writing engine UI stuff, rewriting that in the scripting language itself, which is something we still might do now that I have the longer Stanford deadline. Like, I just think that makes sense. Like, use the engine to build the engine. It also would make concurrency easier, because I do want to do a lot of concurrency stuff, even in the editor itself. Good developer experience. The editor is actually fast, even though it's a dev tool. What? But yes, I probably am rewriting the core engine stuff in Rust as well. I'm going to write as much of it in the scripting language as possible, because the scripting language is going to be fast. Might as well use the scripting language for as much as possible. In the same way that a lot of Unity's UI is written in C#. For better or for worse. Mostly for better. Mostly for better. Do I have any other things to figure out? Yes. Yes, I do. Cannot compile Brane script compiler. Get const. Okay. We just need to change this to an I. And there's probably a couple more of these. Never mind, this is the only one there. And I did save this, right? I think so. Yeah. And assertion fired. When we... Oh, not yet implemented. What is not yet implemented? That's an error that I put in somewhere. Somewhere, I guess. If we go up the stack far enough, we'll find it. Brane script looks kind of like Rust. Is it also similar in functionality? I'm planning to do a ton of stuff very similar to Rust in the language. I don't know if I'm going to implement a borrow checker, mainly because I think that would be... I don't want to scare off all the game devs. I might do, like, add one in later as an optional option you can toggle. But for, like, everything else, like traits... Definitely doing traits, doing enum-based checking. I don't know how long it will be till I get match statements in. I very much would like to do match statements. I guess under the hood I could just implement them as giant if-else blocks, which is kind of what they are. Jumped tables. I can implement jump tables in certain cases. But that would be dependent on optimization mostly. In the bit code, I guess that would just be a switch statement. But for everything but the borrow checker, it will be kind of like a reskin of Rust, but with a lot of concurrency stuff added in. Abstractions over concurrency and like asynchronous and threading stuff. What these square brackets are? So that's because this isn't a function, this is a pipeline. So the square brackets are kind of like a way to say every like little function body looking thing defined in here is a pipeline stage. So the way that Brane script abstracts concurrency is... Oh, I did not want to do that. Send me back. There we go. The way that we abstract concurrency is every single one of these pipeline stages are bits of code that can run without there being any break in execution. Like, I don't want to do an async keyword. I feel like an async keyword abstracts over too much. It makes it a little bit unclear about like when the breaks in the program are happening. You're basically pretending that this is when you use the async keyword, you're pretending that your program is single-threaded. And I don't want to pretend the program is single-threaded. I wanted to make it easy to do multi-threaded stuff. So the way the pipelines work is every single one of these stages can operate completely synchronously. Like, they don't ever need to wait on any information. They just run and then they finish. And then to the next stage, they can pass values that the next stage will need to wait on. So I have like this dependencies field, where if I spawn any other pipelines inside of this pipeline stage, I can say, hey, wait until those pipelines are done before running. Or wait until these values are ready. So this is where you'd usually put an async keyword. Instead, you pass multiple values in, so it incentivizes coders to wait on multiple things at once instead of waiting on one thing at a time. Make the most efficient thing the easiest thing to do. So this next stage call moves us to this stage here. I'm not actually showing off any actual concurrency here. because there isn't anything to actually await on, since this is the simplest case possible that still has pipeline stages. But yeah, so this runs, and then this runs. And if there was any, like, asynchronous things to wait on, they would happen here. Like, let's say we did a network request, like we did let fetch equals, get request, API address, and we did this, and then we passed this into here, like fetch res is equal to fetch, and then I could put inside of here we need fetch res, which is like a HTTP get result. And this is all like pseudocode right now because none of this is actually implemented. And then by the time this pipeline stage runs, this fetch result will be like fully resolved. So you won't ever have to do mutex lock, for instance. It'll be impossible, as impossible as possible, to completely prevent mutex deadlocks and similar things. You just go do all my stuff to request information, and then next stage you do all of the stuff with that information, request the next bit of information you need, and then continue on. Kind of this request, use cycle. Keep using my threads manually, thank you. I mean, to each their own. Do you actually write, like, heavily multi-threaded things, though? Or do you write very loosely multi-threaded things where you try to avoid as much multi-threading as possible? Because, like, that's what I do outside of, like, async Rust with automatic, like, the Tokyo runtime, which I don't want to use because it feels too abstracted. And, like, I ran into so many mutex deadlocks with that system. See, what was my... Try to write my code so it works, maybe, and try to add multi-threading where it's maybe, but probably not needed, and where it's needed, I make an educated guess that it's not needed. Yeah. So basically, the reason why I'm writing Brane script like this is because I just want all the threads being used, and I want people not have to worry about, like, should this code be multi-threaded, should it not be multi-threaded? Just let the runtime decide. And then everything's written in such a way that it's not an absolute pain to then change stuff to be multi-threaded. You just have to go, oh, my code is already multi-threaded. Maybe I need to change, like, the actual algorithms themselves so, like, the stages are more efficient. But it's like, performance by default is my philosophy here. Let me do a ton of work so you guys don't have to. Maybe you'll have to learn some things, but you won't have to do work. Let's see, I'm gonna reference my old version of the last push I did to Brane script. Brane script. Is this compiler? Where am I? This is librs for something. Build int add. Line 32 pointer stack offset. Okay, this is the compiler. No, runtime. This is the runtime. that was my old implementation of this that I had deleted. See, that makes starting threads easy, but it doesn't make communicating between threads easy. I can do spawn a new thread all day. That's easy. What's hard is having a spawn thread, having it talk to another thread, and what you're describing is a thread pool, which is like the step above raw spawn thread, where it's like, oh, spawning a thread takes time. Let's just have a pool of them. Virtualize it. Const int from string is the thing that they do for just create a global variable referenced in both threads when I need them to communicate. Do you at least throw a mutex on there? Or have a mutex by it? Or make the value atomic, so you don't have race conditions? There's like so many concerns that go into getting multi-threading working well that I do not want to have to teach game programmers how to use. Why does this have to be U64? Now, why would you need to sign extended? Alluvium const int of arbitrary precision. Then this is how many bytes it is, but it calls it words. Wait, isn't a word 2 bytes? No. No. A word is 1. Because a D word is... No, wait. A D word is a 4-bit thing. They're usually programmed in Python. Okay, Python is probably saving you, even though there are mutexes and mutex locks in Python. So Python may be like, I don't know. You might want to, I don't know. Well, it depends on how mission critical your Python is, I guess. Is that learning a new language is already a turnoff for people moving from something like Unity, but your language is fundamentally different from differently structured than conventional languages. Yes. I was like flip-flopping between making it as similar to C# as possible, aside from just the pipelines thing, as like a let people carry over, but I'm like, do I want to, like, legitimately, possibly heavily nerf what I'm building just to help with the adoption curve? Or do I want to make something, like, that after you learn it is potentially significantly better? And a better, like, better to use long term. Like, after they... use it, maybe they'll be able to fall in love with it instead of like begrudgingly using it like C++. Though C# is a good language in terms of the likability scale. And I'm like, I would much prefer to have a learning curve and then have people like it and have myself like it, because I am not going for like I'm not doing a to the moon startup. I'm doing like something that I want to be sustainable over the long time and not blow up, make $1 billion, I'm a billionaire, yay, and then I just go off and do something else. No, this is like what I want to stick with for a long time. So I don't care as much about the initial adoption curve. Like, it's important, the onboarding experience is very important, but I'm not going to nerf the tools to make it easier. I'm going to make the tools better, easier to use, but I'm not going to nerf them. Or make them, like, the editor will look like Unity, but it won't function like Unity. It will function better than Unity. I mean, they can do single stage pipelines, which are essentially functions. Like, what most people do, or at least what I do when I learn a language, is I go to the examples, and then I just, like, find example of thing I want to do, copy paste, see how the grammar differs from other languages I already know, and then I'm basically good to go. So at first I'll go, this is a funky looking function, because most of my examples at first are probably just going to be single stage, and they'll go, oh, this is a funky looking function. And this part here, this is going to be implicit as well, so it will just look like this. Like, this looks very close to a Rust function. It looks exactly like a Rust function that's returning a, like, anonymous structure. So I can just, like, explain, like, since this is a language that supports a nice node graph, all function arguments need to be named so that the names show up in the node graph. Cool, they'll get that. And this is a pipeline, not a function. They'll go, yeah, okay, I get it. It looks like a function though, so it's probably a function, but we just call it a pipeline. And then you're able to get started with just this, and it looks very similar to a function, just with grammar that you're gonna have to reference. And then eventually you can add on the other stuff. Now, what major engine is using Rust as a scripting language? The Rust ones. They aren't technically majors. Like, I heard Echo was written in Rust. So there you go, there's your AAA quality game that was written in Rust, that is in the VR space. And like I said, I'm not putting the bar checker in there, because I think the bar checker would dissuade too many people from using it. But then again, you even have web devs learning Rust. So even then, I don't think it's a total turnoff. I don't care about it being unfamiliar. The entire thing that I'm building is going to be unfamiliar. What matters is if it's good enough to get them to switch over, not if it's the sucky in a way that's familiar. Float sub-arguments were not both float values. Huh? Float, f sub. So this is a... This is a problem with the compiler. Why did I put f sub in the... integer area? Let me make sure I did this for addition too. Or didn't do for addition. Integer... Well, I put integer add in the float section, so... Let me just double check. Integer... float... signed... unsigned... floating point... signed... unsigned... no floating point. Cool, it ran. This time we have start plus add. So the first one what will be unchanged, we get 8. But then we do 3, or it should be 8 minus 11. And we get 3. That shouldn't be the way that it'd be. Because I see here the stack value that gets printed out is 3. Three minus 11. So that is incorrect. Look at the intermediate representation, what it looks like. So this is correct. We do argument constant I32 4. Maybe it's the constant. Maybe I messed up the constant loading and it just... Well, no, because... then it wouldn't have subtracted anything from it. It subtracted 5 from it. Because 5 plus 3 is 8. 8 minus 11. Well, 11 minus 8 is 3. Maybe that's what's going on. So add 2. Value, add 2. Are those getting swapped? So it should be 5 plus 3, which is 8. And then 11 as our outputs, so 8 and 11. One goes completely correct. Then 1 should be doing 8 minus 11, but it does 11 minus 8. So let me just check here, like our left and right sides. So Here we go. So we want... This would be isub. Left. Oh, yeah, I did swap them. So we want left. Did I swap all of them? And this, my friends, is why I'm going to write very extensive test cases before telling anybody to use the language, because I can't trust myself to not be stupid. Left, right, left, right. I mean, I didn't need to swap the addition back. That would have been fine. But see, this is an open source project, which means other people may, if they wish, contribute to the code base. And I want them contributing to the code base to be as little as work as possible for me. And you're like, wait, other people doing work for you is more work for you? Yes, because I have to make sure that what they made is actually good. That is one of the reasons why I swapped to Rust, is because now I know that they probably have much less of a chance of doing pointer exceptions, so I don't have to manually check all their code to make sure they're handling memory correctly, most likely. Unless I do a find on their git diff and I see an unsafe in there. Now I don't need to worry about that as much. And, tests are one of those things where I can go, hey, did your thing pass all of the tests? Ah, that is a green check mark on your Git pull request. Awesome. I know you at least didn't break anything. And if they did, delete all the tests, that shows, I can just check every pull request and, make sure they didn't, remove RF, the, tool that they added, the test directory. I can also see whatever changes they've made to the tests and see if they make sense. So, basically, I'm, trying to do as little work as possible to make it more feasible for other people to contribute code to the repository. Okay, this is now -3. That is correct. That is what we wanted to be. Subtraction is now implemented. What if I do multiplication? So you admit you're being lazy. Yes, by making an entire scripting language, I am being lazy. Want to do slightly less work. Okay, 8 times 11 is indeed 88, so that is working. Let's do division. And if I want to be really spicy, I can try out floating points next. Actually, never mind. I don't have any variable casting, so I'd have to rewrite everything. I don't want to do that. 8 divided by 11 is indeed 0 if you're doing integers. Let me swap this around so it's add 2 minus value, or divided by value, and it should be at least 1, because integer division rounds down. Yippee, it is working. We now have basic math operators. So let me make sure that okay, the oxidized branch has been deleted, so we need to we will... Why would they be overwritten? The math works. When will meth get implemented? I'll give that a 6-month time horizon. Whenever I actually get medicated for ADHD. If that ever happens. Wait, right, left. What am I doing? Oh, whatever. You'll get the point across. The arguments are wrong. I don't have to want to... here's what I'll do. We will do a lookup on the entire thing for right, comma, left. And do replace as left. Right. There we go. Now the error messages are correct. Oh, what was I gonna do? Right. Get stuff. Okay, I haven't committed anything. Main does need... Oh, wait. I know what's wrong. I do get fetch main. What do you mean? Okay, how do you... Wait. Can I do get whole... like that? Yes, I did mean with 2 dashes. I put 2 dashes there. Really easy. Just ask any shitty guy. I'll give you without having to get a prescription. Imagine a world where drug dealers only give you drugs if you have an illegal prescription. That would be funny. It's like a thing being like, ah, yes. I know this guy's good for it. Legalize anabolic steroid. Let's see. Can I have it do... If I do get check out origin main, like this works. Let's see, get branch from origin. Get branch from specific branch. So if I do git switch create, or let's see what switch help. So there's create. There's also hopefully you figure out how to use git. See, the thing is, I want to switch to main, but I need to pull main before being able to switch to main without... Actually... That might have just done it. But, NVim nuked itself, as it's been doing recently. Me and my... Okay, so I did pop the stash. Changes not... Okay, so that worked. That was weird. Let me just make sure the changes actually... I mean, there's my changes there. Called a pharmacy? Yeah. Okay, so that is... not work. Yeah, unless I swap those around again. 8, 11... I did swap them around again. Okay, so it is... It is working. Yeah, it's working. I remembered the git stash is a thing, and I can stash before switching branches, and it won't nuke all my stuff. So we added native type operators. So we can do addition, subtractions. We can even do modulus. Let me test out modulus. So we'll do 11 mod 8. So that's the remainder command. Ah, there it is. That shouldn't be how that works, right? Let me actually look up how the remainder function works as opposed to modulus. The value is 8. Current value is that. Like, it's getting called, so... Wait a second. I made it be an unsigned remainder. Which I don't think matters for positive values. But maybe it does. I'm glad I checked that. It's still saying 11. Oh wait, what's this? It looks like a floating point remainder. It is a floating point remainder. What? Right as I was about to sign off the stream, I get another rabbit hole. That's okay, I can go till 6. We'll get remainder working. But if I do build float... Yeah, there's a float remainder. Why did I just assume there wasn't? Well, it's because in other languages, the modulus operator hasn't worked. As expected, but I guess, like... Like, it exists. The float remainder! The float modulus is real! But I do need to figure out why remainder isn't working at all. Oh, did the Tuesday Newsday get posted? It did! Let's go! I need to watch that before... yeah. Thank you. I'm guessing you're heading out? Oh, that was 2 minutes ago. I may have missed you. If you were heading out. Or if you were wishing well to David. 10 minutes after he left. Modulus. Mod. Why mod? No, mod. Because this, the remainder after that, This is compiler, right? Compiler mod RS? Oh, it's because, yeah. I do rem here. Instead of doing this, we want to add in another write. I'm like looking for a switch case where we're referencing the value that we're gonna write, but we can't reference it because we haven't written it yet. So we need this to be frem. And that is the only thing that we change. And we're done with this thing, aside from... Oh, no, that is the only thing we do. And then what was I going to... Right, we need to do on the actual back end. Now, I know how I want the actual intermediate representation to represent the arguments of this. Let's see how backend modRS. Let's implement floatrem. Remainder. And it just says left hand, right hand side. So I guess we have to see what frem does to fix it. The remainder from the division of the two operands. Implemented as a call to libm's fmod for some targets, and using the instruction may thus require linking to libm. Oh. That's not great. So it means it might not always be supported. So I may have just wasted the effort of adding it in there. I mean, I can just implement it on the runtime side if it isn't implemented. If that ever comes up, this is something that I very much like, would be able to have a native modulus operator on floats. So I'm gonna keep it and then just deal with it implementation side, abstract over it. From the unsigned division of its two arguments. Yeah, so this should work. Must be integer or vector. Let me just make sure that this is actually the correct thing. It should be a signed remainder. I add, that's an offset. Alloc store, alloc load, store, alloc load, store next. I don't see it in here. This is our struct offset. Then we allocate I32, we store, allocate, we load, we store, we allocate, we load, we store. The operand just straight up isn't in there. And it, like, needs to be, and there would be a message if there were any errors. Am I blind? No. Here, let me check the, So this would be srem. And I do have it as srem in the print output, but I don't see srem in there. when I do the modulus operator, I call rem. Let's just put a breakpoint on there. Is this even getting called? Let me... Might go all the way to the parser. Add, subtraction, division. But no modulus. It's just straight up not implemented. Oh, what order of operations would the modulus be? I could put it in the same section as division. I think it makes sense for it to be in the same section as division. Then in here, when we do binary expression, wait, am I not doing precedence for these? Oh, that's scary. I think higher precedence means it's more likely. From the look of my other code, that is how it works. So I'll add mod in there. And do I want modulus to be higher or lower precedence? I want it to be higher precedence than add. For... we'll just put it in division. Or in the same precedence as these. Or now. Okay, that generated without complaint, so we will commit this. Then This will be add the modulus operator. Now would also be a good time to add bit shift operators, but I'm too lazy to do that. And then we need to go and get the get hash ID for that push. Just copy that. Sorry, I did it off screen. Then we go to our cargo. Actually, no, not the cargo. Not that one. In here, I bet I could make it a workspace dependency. I'm going to swap out this hash for that new version. Doing it this way is nice because that means if people want to pull these commits for whatever reason, the compiled like parser will always match up as well. So now we can go back to the compiler and it will complain that this case is not handled. And also that type doesn't exist anymore because it was auto-generated with all of the names of every single possible case. We want this to be parser, not compiler. Send me to the error. I'm in the correct file. Here you go. So this is add struct call div expression mold. It is the struct. But the type that we actually want is expression context. This expression node is child is equal to that. So that just adds on the mod in the middle there. That should add one last thing here that is mod, and it used my using definitions. And I'm going to badly spell it because Rust won't let me call it mod, because it's looking for mod as a keyword. We'll call this binary operator mod. Modulus. 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 Should be something like 3. Same as subtraction. Yippee! That is the correct value to return. Let's go. And then if we did something larger than 11, like if instead of 11 we did something like 24. 24 modulus 11 should be 2, I think. Oh, what did I do? No. Oh crap, I haven't been showing Twitch chat in a while. Doesn't matter, I don't have any viewers on Twitch. Oh, it says I'm offline on Twitch. What? Wait, I'm not streaming? Oh, no. Twitch failed to stop streaming, or start streaming at all. My YouTube multi-stream is still fine. Okay. Have I been talking to myself like a crazy person instead of talking to myself like a crazy person with a crowd? Oh, wait, I'm modulused by 24. That should still be 8. Good, isn't it? Actually, it wouldn't be. Dang, I have to, like, actually implement this. Compiler side, don't I? Because I want remainder to be still correctly the remainder operation. We'll call this mod instead. That way it's like clear that this is in fact the modulus operation, not specifically the whatchamacallit, remainder operation. Well, actually, that should work. Like, you think about it. Should be fine. Wonder how long Nimsoni spent on his back and stuff, knowing before it really started getting the viewers from showing it off and stuff. I don't know. Because, like, his content was, like, super polished from, like, before I was even watching. I don't know. His content is definitely more polished than mine, that's for sure. I need to up my game. A lot. Oh. Wait a second. It's because I'm doing... This value here is 8. 24 is divisible by 8, so it's working. Zero is what you would get when you mod that. Yeah. And then, yeah, if you swap them around, still 8. Okay. I'm gonna do that, go back to main RS, and choose something that isn't divisible by 8. Let's do 6 instead of 24. Because this needs to be the smaller number, and I was thinking it needed to be the bigger number. Because I'm dumb and don't understand how my own language works. Or math. I don't know math. I need to know math. There we go. Yeah, that's like a very clear example that it is working. Because, wait, is it? What was I looking at? 6. Eight modulus 6 shouldn't be 6. Oh, I'm thinking like, dang it. Stop mentally, well, actually, yeah. I mentally keep swapping the arguments. There we go. That is clear evidence that it is in fact working. Because 8 modulus 6 is in fact 2. There we go. Now that I actually got the example put together correctly, it is actually working. Like, as it's supposed to be working. There we go. I think this is delayed by 1. Oh, it's not delayed by 1 key press. Sometimes it gets delayed by 1 key press, and it is annoying. Anyways, add mod operator, and we don't have to do any weird math stuff because I was just dumb, and it was working as intended the entire time. Just need to add the parser. Okay, it is semi-delayed by 1 key press. There we go. I'm gonna sign off for the day, and we'll be back at it at some point this week. Maybe tomorrow. We'll see. Yeah, it will just I'm not sure how much time I'll have now that I'm like actually like fully starting my studio job. Like, I'm still getting work done off stream, but it's in like smaller increments here and there, as opposed to like, here's my chunk of time where I can do a 5-hour stream. So yeah, hopefully this was fun, and thank you guys for sticking around. See ya.